Hi friends, my name is Narasimha and I am pursuing my BTech in Institute of Aeronautical Engineering College, Tundigal, Hyderabad. So today, as a part of my AIT Tech Talk videos, in the subject of data mining, I want to explain about the topic named AHEC, End-to-End Compiler Framework for Privacy, Preserving Machine Learning Acceleration. So coming to the topic, coming to the introduction. Machine learning as a service and data privacy concerns. So coming to machine learning. So when we talk about this machine learning, so the main motto of this ML is we have to train a model with the different types of type of data set of our requirement, and which have been used for testing with the test images for getting the outputs. So when we want to distinguish between the any of the particles, or we want to perform the clustering or any partition between the data sets, so we have to prepare and train a model. So for that process, machine learning is being used. So coming to this topic, machine learning as a service and data privacy concerns. ML models are powerful but resource intensive. MLAS involves, means machine learning as a service involves sending user data to the service provider, raising data privacy concerns. Trust in the service provider is crucial. So whenever any platform, like platform as a service or service software as a service, when we say, for example, Amazon is there, so it is a service provider. So when we want to, for example, coming to a simple example, when we want to order any of a product, so we are giving some of the information details such as our home address, our personal mail or any number, anything, contact number and contact details, etc. So when the user is giving data to a uh, particular platform, so the main problem which will be addressed is the privacy concern. Means the data of the user should be kept privately, and there should be no eradication between trust between the platform and the user about their data privacy. So coming to this privacy preserving machine learning solutions. So this privacy preserving machine learning techniques include homomorphic encryption, that is HE, and Yozgard circuit GC, and hybrid protocols. HE is computation bounded but non-interactive. GC requires multiple interactions but is communication bounded. Hybrid solutions aim to balance computation and communication. So this will be known further. Coming to the accelerating HE-based PPML. So existing HE-based solutions have limitations. They are inflexible and tied to specific ML frameworks, HE libraries, and hardware platforms. Generating HE kernels is not automated or optimized. So coming to the approaches to realize HE-based PPML. So three approaches include direct HE library implementation or costly and inflexible. So extending hardware ISA means more flexible but lacks automation, and end-to-end compilation based technique most automated and optimized. So this all techniques are used for keeping the data privately, means data privacy should be maintained. So for that purpose, this HE means homomorphic encryption or any libraries and hardware platforms, all are used for the same purpose. So coming to the three approaches include direct HE library, which is costly and inflexible. It's not that much up to the mark. Extending hardware ISA, and also end-to-end compilation based technique. Next. Introduction of AHEC in this framework. This is the main framework which are being discussed in this lecture. AHEC is presented as an end-to-end HE framework. It uses a domain-specific language, this DSL, to describe machine learning workloads, making it compatible with various ML front-end frameworks and hardware. So AHEC automates kernel generation and optimization. It leverages code design to minimize computation latency. Extensive performance evaluations show AHEC outperforms standard implementations in terms of latency. So the delay should be not be there, and also the work should be done very clearly. So in the same way, AHEC framework is end-to-end HE framework, means the user end, and also it will be connected to the server end time. So next, homomorphic encryption, HE. Coming to the definition, homomorphic encryption allows computation, example, ML inference and on encrypted data without decryption. Property, sir. Homomorphic encryption supports two operations, this homomorphic addition and also homomorphic multiplication. You can see the symbols for addition and multiplication in this slide. And also usage in PPML. HE-based protocols enable users to send encrypted data to the server service provider and receive encrypted outputs, preserving data privacy. Coming to next one. This is the high level, that is leveled homomorphic encryption. Coming to the what is level concept, means what is the difference between the H in homomorphic encryption and leveled homomorphic encryption. So difference between is leveled concept. That is what? In homomorphic encryption, that is in HE, operands of addition and multiplication must have the same level in the modular switching chain. Coming to the consistency requirement, inconsistent levels require transforming the higher level operand to match the lower level operand. Leveled approximate HE. So the paper means this information has been gathered from a research paper. So the paper focuses on leveled approximate HE schemes, which can be extended to full homomorphic encryption with bootstrapping technique. Means which can be used in ML algorithms such as bootstrapping techniques, means many of the algorithms such as decision trees and also SVMs all are used for creating a one strong algorithm. So that is about bootstrapping. Approximate HE. Schemes like CKKS support HE computation with real-world inputs while providing only approximate decryption, making them suitable for PPML. Next. Compilers for ML workload. So coming to the TVM, an end-to-end compiler stack for deep learning tech systems that optimize ML applications across various hardware backends. It uses a tensor expression language and program transformation primitives for optimization. Coming to the ngraph, an open source compiler from Intel that optimizes ML model execution by describing tasks as computation graphs and applying graph level transformations. Next. Coming to the AHEC framework, means about introduction to AHEC and how it will work and what is the structure being involved in AHEC framework. Let's look at it. AHEC is a comprehensive framework for privacy preserving machine learning PPML as a service. Its primary goal is to bridge the gap between the diverse ML frontends, such as example TensorFlow, PyTorch, and Kefi, etc., and various hardware backends, example CPUs, GPUs, and emerging engine accelerators. AHEC uses an algorithm or software or hardware co-design approach for automated and optimized kernel generation in homomorphic encryption based PPML across different hardware platforms. So this is the structure of AHEC. You can see the front ends and back ends. So it will be connected between the front end and every back end means maximally. And also you can see the NVIDIA GPU and AMD GPU and Intel GPU. And also this is the AHEC framework. And it's all front ends are connected to the ngraph. Some of the front ends such as TensorFlow and Onyx are directly connected to the AHEC framework. Let's have a look at it. Let's have a look. And next. HE-based PPML protocols. AHEC secure evaluation protocol include 4 steps that are key generation, data encoding and encryption, HE evaluation of MM model, output decryption and decoding. Coming to the key generation, it generates the public and secret keys and is converting raw data into plain text and encryption it with the public key. And coming to the third step, performing HE operations on ciphertext data. Fourth step is decrypting and decoding the final result. So coming to that is encryption and decryption, everything. For example, you are sending anybody want to send an information in the form of Gmail to any other person, but private. Means the information should be only sent, known by the sender and it should be only read by the receiver. No, the third party access should be involved in this process. So for that process, some of the applications used are keys, means the public and private keys has been used for encrypting the message, means for transforming the actual message from the sender to the ciphertext. And for the decrypting the message, means the receiver side, that the ciphertext is been decoded into the actual message. So this is the main process has been involved in this total criteria. Next, domain specific language for HE. You can have a look at it. Look about on this. AHEC employs a domain specific language, which I said before. And coming to the hardware aware optimization, AHEC integrates hardware knowledge into the design loop and models the target device with constraints. Example, threads, registers, memory. Optimization techniques include vectorization, tiling, and data layout selection and threading. The co-design approach ensures efficient utilization of hardware resources. Coming to the This is the actual process which will be involved. Key generation, and you can see the next. Once have a look at it. Coming to the AHEC workflow. AHEC workflow consists of 3 stages that are: stage 1 is describing ML workload in tile DSL. Stage 2 is kernel optimization and code generation. The stage 3 is runtime HAL based execution of tile code. Inputs include ML model description in tile language and hardware constraints. Outputs are optimized executable kernels. Come to the benefits. What are the main advantages of using this AHEC? AHEC enables efficient and automated HE-based PPML inference. It adapts to diverse ML frontends and hardware platforms and optimized for performance. It outperforms existing PPML techniques in terms of latency. Coming to the conclusion. AHEC is a pioneering end-to-end homomorphic encryption compiler framework for privacy-preserving machine learning. And also AHEC performance experiments show significantly reduced inference latency compared to standard implementations and strong scalability with large datasets. Not only AHEC is an only framework used for this process, there are many frameworks. Then also, this is preferable because the experiments conducted by using this framework shows that it reduces the latency, means the delay will be low, but the actual performance of the algorithm will be high. So, thank you, friends. I hope my lecture is useful for you, and thanks for watching. Thank you.